Hey guys, here's the second part of the video. Okay, it's just proportionality. It's just information for you, so just make sure you press pause and copy what you can. I'll move this down. There you go. Okay, let's go ahead and press pause and come back when you are ready. All right, and we'll get this together. All right, so proportionality. We kind of talked about this in the last video, but they are basically proportional if you can represent them by y equals k times x. So in other words, if I can take that constant rate it's changing at and multiply it by x, I'll get my y. Okay, so that's pretty much what we're doing. So to check and see if they are proportional, we have to figure out what is the constant rate on each one of these. Okay, and sometimes we will have them, sometimes we won't. If they are not the same for every single set of numbers, then it's going to be not proportional. Okay, then we can't do that. All right, so I'm going to show you on the table and show you the graph. The graph is always easier, of course, so I'll go ahead and start off with the table. Okay, so right here, let's go ahead and take a look at the cups of coffee versus the total cost. Okay, so the cups of coffee is 1, total cost is $2.75. We have to figure out what is the y over x. Okay, so for the first cup of coffee, we're going to do $2.75. That is my y. There's my y. Here's my x. Okay, over 1. Okay, that's going to find our k. So $2.75 divided by 1 is $2.75. So $2.75. Okay. Let's try the second one. I'll do a different color pen so we don't get too confused. Okay. The second one is k equals $5.50 over 2. So let's do that math. 2 goes into 5 2 times. 2 goes into 15 7 times, and 2 goes into 10 5 times. So $2.75. So far, so good. Let's do the third one. Okay. K equals $8.25 over 3. Let's do the division. 3 goes into 8 2 times. 3 goes into 12. That's 825. 825 divided by 3 goes in 2 times. So that's 6. That's 22. That's 7. And 15 is 5. $2. Pretty much right now on the third one, I'm pretty sure it's going to be good. But I got to make sure. Okay, so k equals 11 divided by 4. 4 goes into 11 2 times with 2 left over. So 8 with 3 left over. So that gives me 30. 4 goes into 30 7 times. 2 left over. 275. So this table is proportional because the constant of proportionality is the same. 275, 275, they're increasing the same. Okay. All right. So now let's go ahead and look at the second table here. Okay. We have, again, cups of coffee. That is our x. Total cost, that is our y. Okay. And we got to find the constant, see if there is a constant proportionality to check and see, are these proportional? Okay. The first one's easy because I give you 1 is your x, because you remember, how do we find the constant of proportionality? Y divided by x. Okay. So y in the first group is $2.90 divided by 1, which will give you $2.90. Easy enough. Good. Okay. Let's go with the second one. My y here is $5.70 divided by 2. Okay, so let's do the math. 2 goes into 5 2 times with 1 left over. So 2 goes into 17 8 times with 1 left over. And 2 goes into 10 5 times. $2.85. See, they're not the same. As soon as you find at least one that is not the same, then this is not proportional. This one is proportional. Okay? And we can check the other ones, but pretty much if you have one in the set that is not the same, it's all going to be not proportional. Okay? So here we have $8.40 divided by 3. So 3 goes into 8 2 times with 2 left over. 3 goes into 24 8 times. $2.80. Okay. And we kind of did this one already over here, 4 and 11. We got $2.75. So this is a table that is not proportional. Okay. So you got at least to check them all to make sure that one of them, if only one of them is different, then it is not proportional. Okay. So that's how you check it on a table. You just divide. Now to check the graph, it's easier because it's pretty much just visual. Okay. So I went ahead and separate these into two parts. Here's the proportional graphs, and here is the non-proportional graphs. Okay. So if you look at the proportional graphs, can you see some characteristics here compared to the non-proportional graphs? Right here, I can see that they are straight lines. So we have straight lines, no curves, they're straight, okay? Also, if you look here, this is the origin, that's what we call the origin. It passes through the origin, okay? Passes through the origin, which is 0, 0. So it does pass right through there. That is how you know it is proportional, okay? So if you see a graph like this, it's a straight line, it goes right through the origin, then it's proportional, okay? You don't have to do any dividing, you can just look at it. Now, the non-proportional graphs are easy too, okay? Characteristics of non-proportional graphs, they're curved, okay? We have curved lines. Okay, they're not straight. And also, here's a straight line, but what makes it not proportional is it's not going through the origin. Okay, does not go through the origin. Okay, so that's how you can tell a proportional graph versus a non-proportional graph. Proportional graphs are nice straight lines that go straight through the origin. Non-proportional graphs could be curved or they do not go through the origin, okay? Because the origin is right here. It's where the X and the Y meet, okay? So that's how you can tell the difference quickly on the graphs if you have a proportional relationship or not, okay? Now, to check, let's check the work to try it out, okay? All right, let's go ahead and try it out now. I'm going to press pause. Go ahead and tell me if the table is proportional and if the graph is proportional. And then press play when you're ready to see the answers. All right, so let's take a look. I'll check all three of them just to show you how it's done. So you remember we're doing k equals y over x, okay? So here my y is 1, x is 1. 1 divided by 1, 1. Okay, so that's that one. Let's try the next one. K equals y is 3, x is 2. 3 divided by 2 is 1.5. Nope. And I'll try the last one just to prove that we are right here. Y is 5, x is 3. 5 divided by 3, 1 into 20 goes 6. 6. It's going to keep on going. So this one is not proportional. All right. Let's take a look at this one. Okay. Now looking at the graph, let's take a look. Is my line straight? Yes. Does it go through the origin right here? Yes. Okay. So I'm going to put here just so we know, line straight. Yes. Goes through origin. Yes. So this is proportional. Okay. Very good, very good. So remember, to be proportional, your constant rate of proportionality has to be the same for each set here, okay? If you're looking at a graph, though, it's easier. As long as it's a straight line that goes to the origin, it is considered proportional, all right? Okay, guys, go ahead and do your Google form, and I'll see you at the Google Meet.